Yes,
Hello.
sir. Yeah.
Okay. Let me go to terminal and I virtuoso and it should start now.
So, sir, just to confirm, before this lecture, only 2 lectures have been done, right?
No, almost total. If you conclude, like not 2 lectures, we started at the end of the September. So total lectures, I think 8 lectures have been done.
Okay, in OneDrive,
Eight.
actually, I can see only 3 lectures, 2 lectures.
Okay, repeat again.
In OneDrive, I am able to see only 2 lectures.
No. The drive, if you click on, you will able to see almost, I think. Okay, I will be sharing you the new link actually. I think that might the old link have been shared by mistakenly. So I will be sharing you the new link, which should be fine for you. Okay.
Okay.
I think that should be fine for you. Give me 1 second. Please spare me 1 second.
No, take your
Uh,
time. Like, you can share after class as well.
okay. No, I have shared in the group. Please check that one and let me know once. Okay, I have shared. Please check and let me know.
Yeah. Mm.
That you can see all total 9 class or not. That might be the old one I sent.
It's showing 7 lectures.
7 lectures. Okay.
Mm.
I will be fixing that one and I will sending you. That's actually
Okay.
the Microsoft OneDrive issue that I don't know why Microsoft doesn't fix it. I
Okay.
will check into that one.
All right, sir.
That is not in my hand. That's a OneDrive issue actually.
Yeah, it's okay. I just
Okay.
want to cover everything, so.
Yeah. You can start with the things which started in the last exactly the I think 21st or 23rd September. You can start working there. In the meantime, I will share you the new link on the
Okay, sir.
complete videos set. Okay.
Okay.
And okay, so like basic thing I will be telling you guys. So who are new today, please other guys spare 1 or 2 minutes so that I can tell them. So when this is our okay, so this is our actually the Linux environment. In this, then this is the terminal. When you double click the terminal, it opens the terminal, and in this terminal, you have to just type virtuoso and should be working. This will be your pop-up window, which is called a CWI window. Okay, see a command interface window. Okay, in this window, you will able to work on your tool. So here should be file, tools, options, and help option should be there. In this tool, if you click here, you will get a library manager. In this library manager, you will be getting couple of options like library, cell, and view. This should be your library. Okay. In this library, you will be working with your, you can create your library. This should be your PDK. This should be all couple of libraries. This should be shell. This should be views. These are couple of things. When you will get into those videos, you will get in much more detail. In a short, this is a very short introduction I'm giving you guys. You are just to create a library, go to files, new, library, cell view, and category. For here, you can make your library. Okay, you can create your library. When you create the library, type the name, whatsoever name you want, press OK. You will be getting a pop-up like this technology file for a new library. Just click on attach a existing technology library, the third option. OK, and select 90 nanometer and then 1 second and press OK. When you press OK, you will be able to find that AAI made. That's a library have been created using a 90 nanometer technology. After you select this one, go to files, select new and press cell view. When you do the cell view, a new a page will open in which will it's a schematic actually. That's a black window. That's a schematic. Let me show you in our weekend one. We are working in the weekend actually. So I will show you there. I'm selecting this library. Go to files, new, cell view. Let me rename it as a tri-state. Okay, tri-state underscore INV. It should be view is schematic, type is schematic, and I will press OK. Okay, when I press OK here, this black window, this is the schematic editor. Okay, this is the schematic editor. And in the schematic editor, we will making the schematic of the tri-state inverter. First, to get the devices, we will click on this symbol, or we can press I option in the keyboard. Okay, this will give the same thing. The same thing only will I for India, that term, or Ireland. Okay, then we will click on browse. We will be going at this 1 second. We will go to the 90 nanometer PDK here. We want the libraries from here. We will be taking this NMOS one. We are working in 1 volt only. So we will go to the higher voltage later. Okay, so symbol select, and what is the value you want, you can select it from here. We are using 600 by 900 actually here currently. 600 by, this is a random value, it's not any measured value. You can work with your measured value as well. Okay, the total width should be here, and let me make it as 900N. 900N should be here. Okay, and we can put it somewhere here. Okay, 1 and 2 should be there. Okay, then we can go here, we can go for the PMOS, browse again, and we can go to PMOS here, and then we can, let me do it as 600 by 900. 900 it should be, and height, and then we can take the devices here. Okay, 1 second please. One here, and should be one here. Okay, when you are done with this one, so this is how you place the devices actually. So this is how you place the devices for your like any device. When you are making any kind of schematic, you can put the device like this. Okay, is the brief introduction easy for you guys, Rahul and Yashwant?
Yeah, yeah,
Can you
all good.
confirm?
Yeah, but I will need to watch earlier lecture first. But yeah, all
Yeah,
good.
yeah, sure. Anytime you can watch them. You can anytime you can watch them. You can, if you face any issue, come back to me. I will be helping you guys out. Okay.
Yeah, thank you, thank you.
Yeah, thanks.
Give me 1 second. Give me 1 second. I think this schematic what I have is not correct, or whatever it is. Let me check once this one. Or it tri-state inverter. This should be right. CMOS transmission gate symbol and logic one. Okay, should be fine. Okay, now it's correct. We will be connecting for this one. We can use this wire. Okay, then we will be selecting this one. Then we will selecting this one. Okay, this is how we can create the tri-state inverter. And then we will be selecting this one, and I will be aligning it here. Okay, then we can connect these two guys. Let me do one thing. We can connect them, and this should be one, I think, is a bar, and another is a C bar. 1 second. Okay, This is the input. This should be our input actually. Let me make it as a in for this side, and this should be enable bar E N ENB, enable bar. I'm making it as the enable bar here, and this should be EN. This should be only EN. I'm keeping it as a EN only. Okay. Just remember the B where I'm putting, that's a bar actually. Okay. That should be the bar. Then we will be connecting the bulks. Then this is the bulk actually been connected at this level. This bulk should be going here, and this bulk should be going here. Okay. Remember one thing, actually the PMOS bulks are connected to the VDD, NMOS bulks are connected to the VSS. But here two PMOS and one PMOS and one NMOS bulks are connected to their sources actually, but these sources are not VDD or VSS. They are completely different. So your substrate should be different at this case. Means when you are see if your substrate actually the substrate are generally connected to the ground, okay, and for a p type it's connected to the vdd because it's isolated with the n well, but for this case it is a different concept will come. We won't be able to align the nmos and pmos with them. Earlier what we are doing, we are connecting all these pmos and nmoses, right? We are correcting them actually. Now we won't be able to correct them. Either we have to change the device, either we can change the device. Without bulk device we can use, which should be directly connected to the ground. If we are using this device, let me show you that device as well. One second. I don't know. HVT underscore 3, it should be right. It should be okay. 1 volt. This should be okay. If we are using this device, then it's fine, then this is not required. Okay, but if you getting confused, because on that case, if you are connecting these two bulks at a same level, you will get a lvs error. But if you see the bulks are at different level, because this, if you select this net and query on it, it's a net 11. Okay, and this will go and connected to the net 12. This will be changed to vdd now. Okay, so these two are different. So the substrate on that point should be that n well should not attach with each other. If you are attaching, then it is a big mess. It will happen. It will not work in the lvs. The lvs will not even pass. Okay, so for that one you can do one thing. Either you separate the devices completely. The device, none of the devices can match with each other. You can just only connect their uh what I can, you can connect their oxide, but you will get a drc error. What happens when two n well of different potential are there, they should have the zero point 0.6 micrometer distance minimum. So you have to maintain that one. To remove that one, you have to like we can do the both test cases. We can do both the test cases. We'll try to do that one. Let's first do in that way. First, let me do it in that way once. Let me take this guy once, 1 volt underscore 3, and let me do this one this fashion once. Then I will be doing in that fashion also. Once, let you give me 1 second. Let me do it in underscore 3. I am typing because I am getting that library. Okay, in which I will be just deleting this guy from immediately from here. Okay, it should be fine now. Then I will changing this also to the underscore 3, and I will making it like this. Okay, and let me delete these terminals from here, and let me change this also to underscore, sorry, underscore 3, and make it here. Okay, first start with this one, then we will go to that. different bulk connections. Okay. And then let me change this one also to _3, and let me delete this one once. Okay. So here the bulks are automatically connected to this one VDD. See, this is also VDD. It's written here, bulk connected to ground. Bulk to ground. It's automatically connected. You do not need to touch this one anything. Okay. So in that one, we are connecting them manually. So manually, we could have done it to the VDD and VSS, but as per the schematic, we should not do that one. But it depends, actually, how you want to bias the devices. It completely depends upon a different test case scenario and how you want to, like, I can say how you want to actually bias this device. If you want a VDD connection, that's still fine. If you want to do it from that connection, that's also still fine. Okay, it completely depends upon your convenience, your schematic output, what you want actually. So it completely depends upon that one. Okay. Is I am audible to you guys that I have to check this one because many times the connection disconnects from us.
Yeah, yeah. Yes, sir, you're audible.
Okay, okay. Let me make it as a VDD. Let me, and for VDD, we'll use input output, and this one I will put it here, and then I will make it as a VSS. Okay, and it should be fine, and I will connect it here. So if you look into this one, this is our schematic, and then I will do save and check save. Okay, if any warning comes here, you will get to know the results. If the warning doesn't come here, there should be like your device is passed. Like if you don't find any errors here. Any error here, we will get to know all the things that our device is okay now. We can go to the next hierarchy to work on that one. Okay, 1 second. Okay, we can go to the next hierarchies to work. To do go to the next hierarchy, what we
Hello,
need to do here? Yeah, hello.
hello, sir.
Who's
Sir,
this?
I have some. I'm Arshad.
Yeah, yeah, Arshad, tell.
I have small note here.
Yeah.
PM1 and M1 NM0Y you have connected to enabled, sir. Now
Which
above we
one?
have connected here.
No, no.
P.
Yeah, yeah, tell,
There
tell, tell.
in PM1 and in NM0 the gates are connected to enable, sir.
No, this is a tri-state inverter. This is a tri-state inverter actually. I will be telling you the tri-state inverter, what it is, what is the significance of that one. I will be telling you. Okay. So to operate a tri-state inverter, you need a enable and enable bar. Like if one enable should be there, that should be like a enable and enable bar. That enable and enable bar comes from a different output. From output, it will go to the input part of the enable and enable bar. That two different signal. Hello.
Yes, sir. Okay, sir.
Yes, someone was telling something.
No, no, sir.
No, not you. Other guy was actually. Okay, so we can start now. I think if I am not wrong, a other inverter will be there in which the input of that inverter will be directly connected to the enable, and the output of the inverter will directly go to the enable bar. Like this, I think kind of thing it should be. Actually, that is not required layout. That's we are only making the tri-state inverter layout. We are not making that one. That should be fine if we go to the launch. We go to the layout. Okay. So launch
Sir,
layout Excel. It's yeah, still.
sir, in this we will not connect to bulk, sir. Yes.
No, in this one, if you see, we have used PMOS 1 volt _3, in which one you can see the bulk is automatically connected to the VDD. See, you cannot see the bulk here. The bulk is automatically sorted. In this one, the bulk changing, connection changing is not allowed actually in this one. In this one, you won't be able to change that bulk connection here. For that one, 1 volt you can use. To change that one, you have to do it for force changing. You have to do. So force changing is not required actually here for this device. You can do that one. You can still do that one with the connectivity things. You can go and do that one. But here it is not required actually, because we are trying to connect that to VDD and VSS. Okay, we are trying to connect into VDD and VSS. So if you go to this one, suppose I am taking this NMOS, this is the substrate written here, na substrate. You can go and change. Suppose I want to like make it as a ground 2, suppose example wise. Okay. And let me fix it. I think it will not change. I think that's a fixed value. In other PDK, like if you go to the thing, I think it should change actually. 1 second. 1 second. Let me like GND2 and okay. See, it got changed to ground 2. Have you seen that one? This is ground and this is changed to ground 2. You can change that one. You have to change it forcefully. Okay, so that's a different concept. So you don't need to touch that one for current now. That if you go in that concept, that is a complete deep NVL concept. That is completely different thing. Okay. Well, I will come into deep NVL concept later. Okay, Arshad?
Okay, sir.
For the time being, we can go to this now. Did you receive the Milieu Digital link? Exam link? Hello, Arshad.
Yes, sir. I have received.
Oh, okay. Please prepare for that one. Okay.
Okay, sir.
Okay. So this is the window actually. Okay. This is the total layout editor window. Here in this one, first when you enter, can anyone tell me what is the first step we should be doing here? You guys already have done. Please tell me what we should be doing here actually. Hello.
We have to generate from source.
Grid
Uh,
Grid correction.
Grid correction. Don't forget this one. If you forget this one, it will be a big issue for you later. Every time who are forgetting the steps, write down the steps immediately in your pen and paper and read it twice, thrice every day. You will able to remember the steps now. Okay. At this level, if you make the mistake, then it will be very difficult for you to go forward. If you should not remember, forgot these basic steps. It will create major issue for you guys. After this is done, grid is set now. To set the grid,
Sir,
we'll
after
press E.
this, sir, after doing the generate from source, we can do this. We can fix the grid values now, sir.
No. We can see. We can do anytime. We can do after the DRC as well. But what will happen? The device will get set to that particular grid only. So if some PDK is not properly aligned with the CDF parameter, it will not get aligned to the grid properly. It will create a lot of issue. See,
Sir,
complete it. Yeah, hello, tell.
Sir, if I suppose after I generated the all selected from sources, so if
Uh-huh.
anything changes in the schematics, after that how to update in the layout? What is the option
Like
to
you are
update?
saying that if something changes in the layout, how to update it here. For that one, let me tell
Yeah,
you how to do. Got it.
no, sir. This one, if I change the schematic.
I got it. Let me tell you. Like who's this one? May I know you the name?
Sequence.
Okay. Let me tell you. I will tell you. Give me 1 second and let me give you the example. Let me first generate all from source. Okay. Like first click on all from source here. First go to IO pins. Select all these input output pins and change it to metal 1 pins. Like we can go to metal 1 pin here. We can update it. It should change to metal 1 pin and create as level option. I'm directly doing it from here only. Okay. I'm directly doing it from here. I'm making it as a 0.2 and I'm making it a We can do it this one later also, not required. This create label things, but I am doing it now only to save the time, and press OK. If you press OK, you will get the devices. Now, Shrikant, your question is, suppose we change some any devices. Suppose this device, I am taking this device and I'm changing it to roughly, suppose, so let me change it to 400 nanometer. The length I am only changing, okay? And I am saving it. Now, sorry, what you will do? Now, what you will do? You will go to this one. You will first select the device to check which device. So this device, okay? We will be deleting this device from here. So which are the latest, actually, which are the latest currently available, the tools actually, it has already a automatic updation. It automatic doesn't happen. From here you can do, you can go to connectivities and update from here. Okay. Like you can also do here also. Like, oh, 1 second. Give me 1 second. Excuse me. I think, I don't know it came or not. Let me check that one. Manually, I can do that. I will show you that one also. Let me change to this one also. Okay. Let me change to this one as well. Schematic parameter, components, and nets. Layout parameters as well. And it should be press OK. See, if you now check these devices, these are actually 600 by 900, okay? And in this device, if you query on that one, it is 400 by 900. You got it now? How to update it? Okay. Now,
Sir, connections, sir, connections.
Like what connections?
So if I update the connections, I will delete. Suppose I did some mistake in the schematic connection. So after that, again update and how it is updated in the layout.
No, connection you cannot update. Connection you have to make it again, routing things. But the device you can update. Suppose in that one we have made 400 by 900. You can go to connectivity, go to update, go to components and nets. This update layout parameter should be ticked on here. Okay, it should be ticked on here, and then you can just press OK. You will see that device has got shrinked because as per the point of view of length. Okay, these are the thicker width, these are the length, less length. This is the high, the length is bigger in this one. It got updated. One other way is also there. You can just go and delete this device. Okay, go to select from source, generate select from source, go here, select this device, come back again to layout, and you can do it like this also. So both the steps are available to do. It's everything, it depends upon your convenience actually.
That
Okay.
is okay, sir. Actually, suppose can you go to schematics? Sir?
1 second, let me fix it. Yeah, tell now.
So if I did some mistake connection, suppose
Suppose
output
you
I
made
given
this
there.
suppose you made this connection as a mistake thing. Okay, let me
Yeah,
delete it.
yeah, yes, yes.
It should be connected as example. It should be connected to somewhere here. Let example. Now you want to change this one. Then you have to and this device parameter also got changed. First, you have to change the device parameter. First step. Then you have to go to that particular net which was connecting earlier like this to this one. You have to delete that net immediately. After deleting the net, you have to from here to here simply. That only you can do the updation. Routing point of view, if the routing
It
is
will need
changed,
to update in the layout, right?
like I told you now that this device you can automatically you can change the device parameter.
Hello.
The way I told you. Hello.
Yeah, yes.
And then the routing point of view, automatically routing doesn't get changes. Routing, you have to delete the routing between them in the layout, not in the schematic. Schematic, you have to, in the layout, you have to delete that particular routing. Then you have to connect the routing according to the schematic which you have updated. That should be manually done.
Okay. Sir, actually, same, whatever you done, right? Same the changes. So I updated routing also. Then again I updated in the schematic. So then again, I need to change routing, right?
Routing you cannot change automatic thing cannot be changed automatically. It should be done
Again, I
manually
need to
only.
delete manually, sir. That is
That routing you have to delete first, then you have to route again that particular point. See, generally this
okay, sir.
mistake doesn't happen. This is a major mistake actually. So what happens if you are routing? The routing planning is there. Absurd routing no one does. Okay, so when the big blocks are there, you have to do the routing. The schematics are first finalized properly. Very little changes can be done. Like some very little changes happen. If it happens, a major change happen. That is very rare actually. Like every time you cannot do like multiple hierarchies is there, many approvals have to be taken, then only that kind of big level of change, that means you are making the whole thing from scratch again. Many time it happens in the industry that you have to, that schematic changes was there, a major change have been there, due to which the whole routing only have to change, means that you have to do the floor planning again, and then you have to work on that routing completely different. If something is reusable from the old one, it will be done. If it is current, if it is not possible to reuse the old things, it will be completely changed.
Okay, sir.
Okay, now we will be going to these devices. We'll be taking this device here. Okay, now let me fix this both things side by side. It will be easy for you guys to understand. Okay, let me fix it here. Let me bring this guy up till this level, and let me put it somewhere here. Okay, and then I can do one thing, like this is the device. Okay, first device, this should be connected up till this level. What I will do, I will take this one up till here, and I will try to place both of them to each other. I will just simply take them and I will do it. So see, this as a problem many one has asked, actually it is getting shorted, right? Let me first bring this one also here, and this one also here, and it should be like this. Okay, so this device should come at this level, and this device should come at this level. Okay, 1 second please. Okay, and this device should be like this and like this, and then if I merge them, if it is both are merging, it's still fine. Both should have same identical orientations, identical characteristic. If one is having this metal one here inside this one and one doesn't have, then that's a concern. In this case, both are actually joining with each other. It's still fine. Connection wise, both are same. Both cases are same. But here, what is happening? They are joining the oxide directly, rather making any metal connections here. Okay, this should be clear to you guys. So if you want to fix that one, what you have to do, you have to launch back to the layout L once. Go to the layout. That's a PDK issue actually. Come back, and then you can do one thing. You can align it again properly. You can align them. Okay, and this should be fine. Save it and again launch back to layout Excel. Again launch back to layout Excel. Now it is okay. Now it should not go back again like that. Okay. Now what I can do here is, see, this connection is already done. This connection is already done. My motto is to connect this one, this two, because this is connecting at this level. Okay, it's connecting at this level. 1 second. These two should be connected. To connect them, I will be using a metal one track. I will do the path, and I will be drawing the metal like this from here to here. Okay, and I will join them completely. Once I join them, it is connected, and I will change it to 0.26 micrometer immediately. Okay, this is the width of the metal we are using currently. Okay, and after this one, we will be doing one thing. We can just take our option O. M1 to poly, and I will do both the things like this, and we will be able to put them somewhere here, and it should be the midpoint of these two. Okay, these two right side, when you are coming here, it should be the midpoint actually. One second, it should be the midpoint actually. From both the side, it can be like this. It should be 0.7 and the 0.7 from both the sides. Okay. Or if you can do, or you can do one thing, you can go to this device, press query, go to parameters, and you can go down and you can change the gate connection to bottom and press OK. That should also be fine. Okay, that's also fine. We are doing it in this way. Because this way is more advisable from that way. That is the reason we are doing in this fashion. Okay, this way is much more advisable. One you do, you can copy them. One you just do, you can copy them. Simply you can copy them. Okay, let me copy this one also here. We are copying them just. Okay, let me do one thing. Let me copy it again and copy and paste here. Simple pasting can be done here. Okay, done. Then again, we will copy both of them. We will copy and we can do one thing. We can bring them and we can put it somewhere here. Okay, it should work actually like this. Okay, see, it got all thing got shorted. Every connection done properly. Now let me check a parameter. It should be fine. Okay, it should be fine now. In this point of view, if you check, these connections are done properly. These connections need to be done in which these two gates should be get connected. These two gates should be connected properly. To do this one, what I will do, metal one drawing, will do the path, and from the center of this one, as the tri-state inverter, we need to be very precise with the delay. So I am making it in a very precise manner. So I will be taking and putting it here somewhere, and I will making it 0.26 again. 0.26. 0.26, this one also should be. And for them actually, we need different kind of patterns, like one should be here, one should be here, one should be here. But the problem is a different case test scenario. We cannot do it like this. So for that one, what I will be doing, I will be selecting the whole device. Wait one second. I will change this one to partial selection. I will select the whole device completely, and I will be bringing it to below part first. I will bring it to below part. Okay. One second. What happening? This one. Let me. I think that's an issue actually is there. One second, please. Okay, let me do one thing. Let me go to L and switch them back. It should be fine here now only. It should be, let me do it in L only. Okay. First, my question is, I have to draw this track here also. One track I will be drawing. Sorry, I will be drawing one track here also. 1 second, it's not in the middle. It should be, yeah, it is in the middle only. Okay, I will be putting one track here and I will making it as a 0.26 micrometer. But the problem will occur. Actually, let me measure these distances. Okay, it should be fine. No issue is there. And then I will be copying this again and I will be taking this to below, and then I will align both of them. Then what I will be doing, I will be taking a metal 2 connection as well. I need a metal 2 connection to connect them. So what I will be doing, I will be simply drawing them because the input connections are there. Okay, I will just make it a 0.26. 0.26 micrometer. Okay, but the spacing between at this level should be above 0.2 micrometer, 1.2, 0.12. It should be up till this level. Okay, so what I will do in this case, I will be taking this device and I will be simply, so you cannot do absolutely anything. There should be a measurement, there should be a space saving as well. Okay, this is also done. In this case also, I will be copying this guy and I will be putting it somewhere at this level by measuring the 0.12 micrometer distance only. Okay, and I will be taking this device to below level and then I will be freezing these two at this level. Okay, and then this is the minimum DRC we are checking. Okay, up till this level this is done, and from here what I will do, I will copy one more guy from here and the distance between them should be 0.26 micrometer. Sorry, 0.20 micrometer, not 26. It should be 0.20 micrometer. This spacing should be, this spacing should be 0.20 micrometer. Let me go below. Sorry, let me go below. See, 0.20 sorry, 0.2 micrometer. Sorry, it should be 0.2 micrometer. And then this device, I will select them. I will go in the top directly here. And this measurement also should be 0.26. Sorry, 0.2. Sorry for my term. It should be 0.2 micrometer. 2.26, this one, not that one. Okay, and I will switch it back to this level again. We'll switch it back to this level again. And then I will be using the vias, which is our M1, M2 to M1, and we'll make it 2. And then I will align it one here. One should be at this level, and one should be at this level now. Okay, then if you see our all devices placements are done properly, we can now go, let me pull it a bit back. Let me pull it back. Okay, and then uh, after doing this one, I can just go here. Let me do let me check one thing. Okay, let me check one thing.
Sir, basically we use VR layers to connect different metal layers, right?
Which one?
Like what is purpose of VR layer? Just to
Yeah,
connect different
via
metal
is
layers.
to, yeah, yes. Like from oxide to any layer, if you want to connect, you can use the via on that case.
Okay.
Okay. No, it should be detached. 1 second, I'm checking one thing. Top tab, and it should be ticked out. Okay. So up till today, we are drawing these tabs manually. We are drawing these tabs manually actually. We can also do it in this fashion also. Like let me show you once let me show you. We can select them like this. Press query Q. Press common first. Go below. Body type, make it as detached. And then I want it in a bottom. For that one, I want top. For this one, I want a bottom. This one here, and press OK. It will save you some of your couple of times, because it will save some couple of times for you guys. Otherwise, you have to draw it manually. Then you have to edit those parameters, because otherwise the DRC will come automatically. We should not be we should be considering DRC as well, because DRC is a major factor. So every time we are actually considering the DRC things, we are just fixing those manually. Then we are aligning those. So to save the time, we can do it like this also. It will be a much more automated thing. This will be a much more automated thing. You can use it. It is much more easy to use. We can we can turn on this one as well. Okay. Then we can go here and let me launch. Sorry, let me go to launch Excel again. Okay, let me launch Excel again and let me select this pin terminal. This should be connected at this one. Okay, this should be connected at this one. This should be connected at this one. Okay, this should be connected at this one. And let me change it to 0.26 once. 0.26. Okay, I'm just changing it to 0.26, or you can keep it this length as well. Or let me do one thing. Let me change it to 0.20, which could be still fine. I let me then again make it to 0.22, 0.24. Okay, that's fine. I'm just keeping this as a 0.24 only. 0.2, 0.02 less from our that device length. Okay, that metal track. Okay, that's fine. Still not an issue, big issue for that one. Once then I will copy this one, and again I will be taking this device guy here, and I will try to align this one with this level. It should actually work now. Yeah, that's fine. So we are with this one. You can go with this one. Okay. Or you can do one thing. You can change everything to no. I think if you change this one, the VR will be a big trouble. So don't change anything. Okay. Just take these lengths and align them to this boundary only. So this should be your boundary, should not cross this one. And then alignment take and align it up till here. For a top guy, select it and align here. For this side also, I will be taking this one and I will align it up till here. Okay. And for the below part also, I will be taking this one and I will be aligning it up till this level. Everything is aligned for us. Now what I will go to make the screen big and I will try to put the device that this guy is actually okay. Sorry, 1 second. Am I audible to you guys? Hello.
Yes, yes, sir, you are audible.
Okay. Okay. VDD, I will making it as a VDD. This is the VDD. Just putting the pins here. Okay. These are in metal one, so I'm putting a metal one pin here. Then I will be taking a VSS. Please pardon me for today. Today I will be taking only 1.5 hour class. So by 10:30 we will able to close the class today. Tomorrow from tomorrow we will be taking 2 hours because some guys are having exam on Monday. So the weekday guys are requesting to do the class once at the morning. We try to do it in the evening, but they are trying to do it in the morning actually because they need the class actually to do in the morning because they actually need that one too because they have some doubts I actually have with them. So for today, please forgive us. Okay. I will flip this one and I will try aligning this one with this one. No, but the thing is actually it should not actually be like this. What we can do here is we can just take this 1 second. We can leave it or we can leave this one once or I can just take it like this. Let me do one thing. Then let me take it up till here and no, that's not a good idea to do. That's not a good idea. We can just have it up till here and then I can just put this boundary level to here. Okay. And let me pull this metal back. Let me put this metal back up till here. Like this way, this can be fine actually, right? And let me take it and let me put it here somewhere. Okay, now it should be working. Now it should be working. Now let me check the distance between them actually. 0.05. I can ignore this one as well. I don't need this one. I can ignore it. But later also we need to put some things here also. But I can ignore it somehow. Okay, I can ignore this one. Let me do one thing. Let me ignore this one. Okay, let me ignore it. Let me for the time being ignore this guy. We will do the routing in metal one only. We should not do, but for little test cases, we can do that one. Okay, for a little alignments or things we can do. That's a fine, not a big issue. Now what I will be doing, I will be taking this guy and this input should be going for this level. Sorry, this track. Okay, it should go in this track actually. Okay, and I will be aligning it here and I will putting this one at this level and then I will be selecting it and I will changing. I will select, press query, the Q for query. I will click on common and I will then change to metal to pin. Then the whole thing automatically will get changed. See, if I don't click the common, either the name, either this symbol that IN in alphabet or that this symbol that see this square will change. Only single will change. If you press common, everything will change. Whatever been selected. Okay. Then what I will be doing, I will be selecting this one out. This is the out terminal. Let me take it up till here and this should be the out terminal and we can put it somewhere here. Okay, this is the out terminal for us. We're just putting the out terminal for it at this level. Okay, now let me take this one as well, enable connection. So enable connection, I am putting it at this level. So metal 2 is there. I will simply take this one and I will put it somewhere here. Okay, let me take it and put it somewhere here. Select it again, press query, common, and make it as metal to pin. Again, okay, it should be. And then this is the enable B. Enable B connection. I will be taking this enable B connection somewhere here. Our actually area is this level. And then I will be pressing, putting it somewhere here and I will make select it whole. I'll press query again, common, and make it to metal to pin. Simply metal to pin. Okay. For this purpose, we have done this one. Let me go and then we have to put this in origin. To do that one, select this exact point up till here, edit, advanced, move origin, and press OK. Okay, this should be okay for us. So our connection point of view, everything is done properly. Okay. Why happened? Okay. Again, that thing happened. Again, that thing happened. That's not a good thing. Every time this is moving aside and everywhere. 1 second. This is a problem with this particular PDK only. The problem with this PDK only. Let me switch back and then I will be aligning it up till here. Now it should be fine for us to Excel. See, now everything is fine for us. Every connection is done properly. Been placed properly. Now what we can do here is we can do the routing. We'll go to Ashura once. We'll go to run DRC. Our things are set automatically. Run name, run directory, and the rule file. And we'll press OK. Simply we'll press OK. It should run now. 1 second. It should run. If any DRC error comes, it will flag for us. Hopefully, no DRC should come. See, we don't have any DRC error in this one. Like why I did this tap thing here, if we'd have a DRC, like we would have done the tap thing, we could have the DRC error. For sure, we had a DRC error. To fix, to solve, to reduce that time consumingness, I have done this tap thing. It's much more convenient to do. See, no DRC error found. Means our device is DRC free now. Now again, I will go to run Ashura. Run LVS. Okay, run LVS. I will go simply. 1 second. Let me make it larger. Okay, run name, let me T, and let me go and select some directory you can select. Okay, you can select any directory of your choice. You can select any directory of your choice. Then I will go to extract rules, select this one, go to cadence, GPDK90, Ashura, extract rule.rule, and OK. When do you want to cancel it and proceed? What happened to this one? 1 second. What happened? Okay. Simulation. Let me go to the simulation. Okay. 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 Cadence. Sorry. Cadence here. For Ashura. And then extract that rule. It should be extract that rule. Okay. It came. Then we'll put the compare rule. Simply same again. We will go to the cadence. We will go to 90. We'll go to Ashura. We will go to compare dot rule. Compare to an RSF include. We'll go again same way. Cadence 90 Ashura, and then we will go to our LVS include this big this, capital alphabet. LVS include, not the below one. There is other RSF also available. LVS.RSF, not this one. LVS include.RSF. And OK. Everything set now. Environment. We'll press OK and we can run the DRC. Let me run the DRC again. Sorry, LVS this one, not the DRC this one. This is the LVS. Okay. What happened? Bad exit from a child process. Asura will terminate. 1 second, please. 1 second. I think some error happened, right? I think some error happened. Let me get it as this one, and then let me do here is okay. Let me run it. Okay, now our run has been successfully completed, our LVS run. Okay, if you see here, one cell has a net mismatch. Actually, it is saying no extraction problem were detected. Like means one of the cell has a net mismatch. It is saying the net is mismatch in this guy actually. Okay, there's a net mismatch. If you can see here in this one, I will press OK, and I can go and I can see. Let me see what net has been mismatched here. Okay, tri-state inverter. Either the pin should be or the net should have been mismatched. This is the net mismatch is there. Okay. Okay, so net mismatch tool. What kind of schematic? It is VDD VSS. So 1 second. Let me go here and let me probe it. Okay, you can see here our error is here in this one. You can see the error is coming in this one. Why? I am telling you. Let me tell you why. What happened actually. We make this as a we connected this as a device. Okay, and this is a bulk. It has been renamed as a bulk actually. Okay, that is the reason it is flagging the errors. Okay, see, it is VDD we have given, but the as per the device placement, its name is B for bulk. Okay, that is the reason what happened here. Let me select it. And now let me go to property. I think that connectivity option is not available in this one. 1 second, please. I should be getting that. You got what is the error happen? If you go here and you will see that VDD, why it is coming. If I probe it, you will be able to see. That's a probe I am doing. So that's actually highlighting here means I don't know why any things are not available at any description means that bulk is this tap name is bulk and this is VDD. That is the issue actually it is giving. It should have been properly done. Okay. 1 second. I don't know. 1 second, please. Strength manager. No, property editor I want. Okay. Property editor. I will be going here. I'll be going to this level. We'll go to attributes, connectivity. Okay. The bulk, the terminal bulk. Actually, it is VDD. Okay. CDF parameter was PWell node. Actually, it is VDD only connected. Okay, attributes point of view. Okay, actually, this is the reason actually it is being highlighted. Actually, this guy is named as internally as B, this tab part. If we draw it manually, then it's fine. We didn't draw it manually. That's the reason actually we are unable to touch that one properly. Okay. I don't know. Let me body tie detached. Body tap, like what any body connection should be there actually. Then only we will able to change it. Terminal B. We will able to change it from here only. We can change it like top tap true, false, detached. The tap connection should be there actually. Actually, it is not available here. I don't know why. Either you delete this tab placement like we have done here. What we have done here, we can either delete it, we can press query common, we can go down. I can just remove this guy from here. None, I can make it none. I just made it none actually like this. Okay, simply make it like this and then come back common. Again, I will be making it to none actually here. Okay, I'm making it as like this only. And then let me, okay, 1 second. Let me do one thing. Let me first go to launch layout L. Let me do it in layout L only. Okay. See what happens here. I am telling you, let me go to here, common, and I will be turning this detached thing off. None, I don't want. I don't want it. I will draw it manually completely. So that's the reason LVSE is coming here. Okay. That tap is taking as a B connection body and it should be directly a VDD connection. That is the reason actually it is coming. That problem error is there. I'll press OK. Now what I will be doing, I will go to create multi-part path. I will go to FN F3. See, our PMOS is there. We want an end tap for that one. I'll press hide here. Simply I will press a hide here. Okay. And I will start drawing this one, this layer. Okay, and I will draw up till somehow this level. Okay, now what I will be doing, I will be taking this guy at the top somewhere here, and then I will be bring this one to up till at this level, and then I can go inside this one, press query subpart, go to envel, have to edit this one, like I have to make, I will make it as 0.14 and this is all 0.14 and I will edit it somewhere here and I'll press OK. It should come back up till this level. See, automatically it came to our PR boundary level actually. Okay. And then I will be selecting this PR boundary and I will align it here. This PR boundary side, you can see it is automatically came at this level somewhere. Okay. To make it more closure, we can just do one thing. 1 second. There's the 1 second. Give me 1 second. Let me close run. Okay, this is our PR boundary. We can do one thing. We can go query again here, subpart. We can let me go here again and make it a 0.2 and let me make it a 0.2. Okay, and edit and okay. If you now see this one, both are aligned properly. This envel to envel, all things are aligned properly now. Okay, and I will come back again here. If you see. It is done now from here. From this side also I will be doing. I will create multi-part path. FNF3. I will go to PTAP. NMOS PTAP. That's fine, should be. That should be fine actually. Okay. And from here, I will be just drawing that guy up till this level somehow. Okay, up till this level, and I will try aligning them with the top part. With this metal, I will try aligning it. Okay, I'm just aligning it up till this level, and then the distance should be from here to here should be point minimum 1 micrometer. It should be at least 1 micrometer distance. Okay, but for that one, what I will be doing, I will be holding this guy and I will put it somewhere here. Then what will happen? 1 second, why it is not coming up till this level? Okay, okay. So it's point like this. Okay. So now what I can do here is, okay, if you see here, you will get to know what I have done here actually. If you see here, you will get to know the things what has been done. Okay, so this distance should be minimum 0.1 micrometer, this poly to this oxide layer. There is a red layer below this one also, this blue color. A red line is there, okay? That is actually the zero from that should be 0.1 micrometer minimum distance, and I will press OK, press K, and then I will run the Ashura once. Then I will run the Ashura once again. Go to Ashura, run LVS now. It should be fine now and press OK. And let me run again. Let me see what the error comes and what not. There should no, I think there should be no error now. One cell has a net mismatch again. One second. Open tool. VDD probe. I don't know what is the error actually coming here. I think some error is there. What is that error? I'm not getting here actually. Let me go here. Connectivity as VSS. Okay. And then let me make it as a VDD. VDD. And press OK. Now let me go again. Let me close them. Close all these things. Okay. Okay. Now let me go to Ashura again. Ashura LVS and press OK and run again. Let's see now what happens. Again, the same error is there. State inverter. I think that is some kind of a different error, as I guess. That's some kind of a different error actually. Property editor. Let me go here once and let's check here connectivity. What does it says? Source is VDD. Okay, that's fine, but still, I think some error is there in this one. I don't know what's the error. I have to check that one. Okay. So like this is how only you can run the Ashura LVS. So LVS cleanup I have shown already earlier also. So I don't know, some kind of error is there actually. Either it is from the schematic itself only or something is there which is coming at this level. Either due to the device what we have used here. That could be a possible reason. The device what we used here is, I think that is might be the reason actually. That could be a possible reason here. Let's do one thing. Let me remove this guy and okay. Let me remove this guy and do okay. Let me remove them. Okay. And let me remove it and okay. Okay. Now let me do the connection for the let me do it like this now. Press F. Let me again connect them up till this level, and then again I press F. Okay. Now let me do it this one manually, this guy. Okay. Devices should be fine for here now. And let me go again this connectivity. Sorry. 1 second. Let me launch back to layout Excel. Okay. And go to connectivity, update components and nets. All things should I update from here, and here, and this should be okay. And press OK again. Okay. I think that should be fine. Now let me go to layout L again, and let me put it at this level again to check whether it is the connections are correct or not. I will just taking this guy again, and I will just pull it somewhere here. Okay, it's aligned properly, everything are aligned properly. Now I think the bulk connection should be also fine from every cases. Let me run the LBS again. Bulks are automatically together. We have changed the devices now. Okay, I have changed the devices to that normal one. Now let me see. Now see, that's the reason of the device error. That wasn't device error actually. That not wasn't tap error actually. Tap was fine. Tap was fine actually. We can use that old tap only. We can use that old tap. Don't worry for that one. Now see, zero cell have zero malformed device problems. Zero cell have zero level short problems. Zero. It's all are zero actually. Okay. If you want to see the result, press yes. You will go here, schematic and layout match. Extract no extraction warnings were detected. So this is how you can do. You can just now you can go to these devices. You can go here. You can make common. You can change it to detached. You can change it to detached now, like body type detached, and make it to top. That should be also working. Okay. You can delete this. You can delete these tabs, and you can using those also. It will also work now. It was actually due to this device only. This device was not okay actually. That is the reason actually it was creating issues. You can delete these tabs. You can delete these tabs. You can go to that body tie option, and you can make that turn on detached and make it top for this one and bottom for this one. That will also work fine for you guys. Okay. No worries for that one. No worries for that one. Let me align it to this level, and then let me make it origin, advanced, move origin, and press F now. I think, oh, that's fine now. Okay. Okay, up till here, this should be fine. Any questions from you guys' side? You can ask me now. Any questions if you guys have, you can ask me now. If there are any questions. Hello?
Hello, sir.
Yeah, hello. Hi, tell.
Actually, in the devices we have taken the bulk is automatically connected, right?
Huh?
Before, then after that we have got an error, right, sir, in the layout part.
Mm-hmm.
All as we are generating from the source, why the bulk is not connected as per the schematic devices?
No, in that devices, some I think error is there, or some connectivity things that have to be updated in that one. That is the reason it was coming. I have to check that one. So don't worry for that one.
Okay, sir. Okay.
That is a different test case scenario. So we try it. So in that one, some things to be changed. I will see that one. So you can use this device for now. Okay.
Okay, sir. Okay.
Any other questions, guys? Hello.
Sir,
Yes. Yeah. Tell.
sir,
Question.
what should be the length of the device, sir? Minimum.
It depends upon the what is the calculation you have made, na? See, every point of view, you should be knowing the ID current. For what is the formula of ID? Mu COX by 2 W by L. If I'm not wrong, I think 1 second, let me check the formula. The formula, I don't know, I'm not forgetting that 2 or 4 it is. And it is mu COX by 4, I think so. What is like ID? I think that should be 4 as I am not
2, sir.
2. Okay, 2 it is. 2 it is. Okay, it should be ID is equal to mu COX by 2 W by L VGS minus VTH whole square. So if you are using, when using this formula, what is the W? Suppose your desired current output should be like 5 milliamps. Okay, then your VGS minus VTH, this bias, this voltages, and the W by L, you have to play with W by L to get that particular value in the ID. So suppose you are taking the L as this one and you want the W to be changed so that the ID current should be like this, you have to play with this value. So length and W, it is completely depends upon the schematic design, how you are making it. It is not fixed for every point of view. It can change depend upon the requirement of the voltage and current, and what is the biasing you are using. Okay, that is a part of a schematic design actually.
Yes, sir.
Any other questions? Yashwant, Rahul?
Yeah, actually have to watch previous videos
Yeah,
first,
yeah.
then only I'll be able to understand.
Okay, okay.
Sir, just
Hi.
make sure like that OneDrive link is fixed.
Yeah, I will share. I will, let me just end this class. I think by in some time only I will sending you because every day I send the link to you guys. I will just check and I will send it to you. It will be fixed only.
Yeah, okay, sir. It's 1 a.m. for me anyway, so I'll be watching in the morning.
Okay. No issue. No issue. Hi, Abdul. Your first class also today, so you joined this one. So, are you comfortable with the class? Hello, Abdul. Hi, Abdul Ahad.
Yes. I'm
Is it Yeah, tell Abdul. Hello. Was the class comfortable for you?
yeah. The class was very much comfortable.
Okay. Any other guys' queries are there?
Sir,
Hello.
I need to
Yeah.
know.
Yeah,
May
sure. Tell.
Someone is telling.
Yeah. How do you know that exact DRC rules like minimum spacing and minimum width? Is it through repeated DRC verification or you had access to design rule manuals?
I have sent you a DRM. If you see 90 nanometer GPD DRM. If you see
Okay.
that DRM, in
Yeah.
that DRM, all the rules are written. And actually, I'm doing for a long time. I remember those rules for which rules, what is the value should be. So basic things you should be knowing, like everything you not required, like what are the metal DRCs, metal spacings, what are the oxide things, what are the NVL things, this should be you knowing actually. So that thing will come when you practice a lot and you read the DRM. Read the
Okay, I
DRM
got you.
once and practice a lot, you will get those values on your mind.
Okay, sure. Thanks.
Yeah, Arshad, tell.
Sir,
Yeah, tell.
sir, oh, sir, it is good to use stacking all the times. Metal
Stacking.
stacking. Yes,
So
sir, metal
metal stacking, it depends like what is the purpose you want. What is the purpose you're looking? Are you like going to a higher metal to route, or you are doing for an antenna effect, or like you are doing EMIR? What the purpose is there of metal stacking?
I want to go. I want to put higher metals, sir. It is good to use all times, or if there is a
No,
possibility,
see,
like
no, see. For this kind of smaller block, metal 1 and 2 is fine. Why you will go to metal 5 and metal 6? That's unnecessary to go. That will
no,
unnecessary will create the cost of your fabrication.
not like that, sir. Stacking means adding wires. If suppose there is a metal,
Suppose that only I'm telling. Adding via means what? Adding via means you are increasing much more steps of fabrication. Like when fabrication happens, step 1 first metal 1 done, metal 2 done, metal 3 done, metal 4 done. If it is someone up till metal 1, then the fabrication is stopped up that one. If we are doing with metal 5, then the cost will gradually increase na. resource will be used, materials will be used, it will grow automatically. The cost, the steps will increase. So if it is not required, why you will use the metal stacking to go to higher metal?
We can use up to maybe 4, no, sir, if there is for small block.
For what one?
For smaller blocks, as we did in the previous blocks, no, sir.
That is
We
a
have
big
gone up
block.
to
That is a big block. If you
of
see that block, let me show you that block. Let me go to library manager. We can XOR this one, right? You are asking about? Let me open it. If you see this one, we went for a higher metals, because in this one there was no such opportunity to go. That is the reason we went up till higher metal, that up till metal 4. There was no opportunity or no space. Either I have to do routing over the devices directly, or to minimize that routing of the device or routing over the device, I did with metal 4. If I would have route over the devices, then I would have done up till metal 3. I would have used up till metal 3, not metal 4 even. But here I was not I was not routing over the devices. That is the reason I went up till metal 4 maximum. Okay, Arshad?
okay, sir. Okay, sir.
So you have to see the scenario, what scenario is there, how much congestion it is occurring, how you have to pass the congestion. Like you take a bike, when there is a traffic jam, okay, so when you go with a car, you have to wait a lot in to pass the traffic jam. When you take the bike, you automatically go much faster. You take a cycle, you go more faster. You take walking, you be going walking, it is more faster. Of course, you cannot fly. No one can fly. Fly can do can be done more faster. So if you're walking, so this is how you have to avoid the congestion. You have to find the way to avoid congestion, but it should be cost effective. But it should be cost effective in that point of view. So that is the example I gave you regarding the traffic jam. Okay.
Sir, what is mean by auto wire, sir?
Auto via is nothing. Suppose you are putting these two devices. Suppose, okay, you're putting two device, one device here and this. Sorry, and this metal two here. Excuse me. And two here, okay, and let me 0.24. Okay, and let me go here, option O and auto here. Okay. Will come and press here. It will see the via will automatically taken here. You don't need to touch anything. Automatically the via will come. That is the use of auto via actually. That is the use of only auto via. Hello.
Yes, sir. Yes, sir.
Got it now? I think that thing is not available in this one. I don't know why it is not there. Okay. So when you just put here in auto VI, in the higher versions, when you go, you will be seeing area VIA. Suppose you want to put the VIAs in this whole area. Just go there, select auto VIA, and area option will be there, and then just route it like this. Automatically, the whole area where the same nets are there, it will get automatically connected. That is in the newer version. I will show you someday that newer version. I have that one as well.
Means when we will use this auto wire, sir, generally?
So auto via is required when larger, when bigger blocks we work on. We work on a bigger block, then we use auto via. Unnecessary auto via is not required.
Yes.
Auto via is much more convenient and faster. Currently, you are in a new stage. That's why I'm using manual vias. I could have used auto via because generally we use auto via in the industry only. See, analog layout is a big thing. Okay, so in a like a 4 month, 5 month, if you think you will become a master, that's not possible. It is like continuous process, continuous learning is there. Even till date I learn. Okay, so it is a learning process. You have to learn as much as possible. Then only you will get familiar with these things. Okay.
Okay, sir.
Any other
Hello.
questions?
Hello.
Yeah, still.
Yeah. Can you please explain what exactly this grid correction mean during the initiation of layout?
Who's this?
I'm Ishwant.
Like I didn't got your name actually. Let me see.
I am Ishwant.
Yes, Ishwan. Okay. So what is the grid correction? Okay. That grid correction is nothing but that when you do the grid thing, the precision and resolution of the grid are much more precise. Okay. So if the grid are not fixed, if you go to the DRM, that manual I have sent you, if you type their grid, that grid value comes from the foundry actually. In that one, the grid value is written as 0.005. If the grids are not proper, grid means that in that particular point to point only the machine can move. Okay, that is actually the grid value is. Okay, that grid value need to be set in the earlier stage only, otherwise you will get a error like grid error in the DRCs. That is only the grid value is significance of the grid value. Okay.
Okay, got it. Okay, thanks.
Okay.
So, sir, different foundry have different rules, right?
Yeah, different foundry will have different grid values.
Okay.
It changes from organization to organization, like your foundry, not foundry to foundry, technology to technology, it changes.
Okay.
Any other questions?
Sir, could you explain what is the working of this traced inverter, sir?
Tri-state inverter. Like working is, see, I told you na that I will be explain the working later. So I will be explaining it by tomorrow if it's possible. Okay.
Okay, sir.
I told you that I will explain that I will tell that working. Don't worry. What is a tri-state inverter? Tomorrow I will be telling. Okay. Actually, the three state is there. At a three level of state it can work. I will be telling you the everything details tomorrow regarding. So actually it's not a part of the layout. So as per the request of some guys, I did the tri-state inverter. Okay. If
Okay,
there
sir.
is no other questions, we can end the session for today. From 11,
Yeah.
the other guys having the class.
Okay. Good night.
Okay, sir.
I mean,
Okay,
have a
Okay.
good day.
sir.
Okay, everyone. Okay, everyone. And goodbye for the day. And tomorrow we'll meet again. Okay.
Yeah.
Okay. Happy weekend. Okay. And bye.
Thank you, sir. Thank you, sir.
Bye. In some time, the recordings will be available for you guys. Okay.
Thank you.